Hi, and welcome to our webinar on improving data science team productivity using Amazon SageMaker Studio. My name is Stefan Natu, and I'm a machine learning specialist solutions architect here at AWS. I've been with AWS for over a year, and I work primarily with financial services customers to help them build enterprise machine learning workloads on AWS in regulated environments. My recent interests are on secure machine learning in the cloud and operationalizing ML models or doing ML ops. I'm a physicist by training. Over to you, Mark.
Thanks, Stefan. My name is Mark Roy, and I'm an ML specialist at AWS. I help customers design and build solutions, and I'm working with companies in insurance, financial services, and entertainment. I spend a lot of my time on computer vision and deep learning. Before joining AWS, I spent more than 20 years as an architect and technical leader, primarily in financial services. Thanks for joining us. So today we're going to show you an end-to-end example of how you can use SageMaker Studio. I'll give a brief introduction, and then I'll show you two of our newest capabilities of SageMaker, namely processing jobs and experiments. Then I'll hand it back over to Stefan to show you deployment and monitoring. Everything that we demonstrate today is available to use now, and tens of thousands of customers are using SageMaker to solve real data science and ML problems quickly and cost effectively. We've got a lot to cover, so let's jump right in. Here's the landing page for SageMaker Studio. This is our IDE for machine learning. From here, you can easily launch new notebooks, deploy and monitor existing models, or even use Autopilot to generate models on tabular data. Today, we'll be using Studio notebooks. And you can have many notebooks open all at once, and you have the flexibility to run them on a single instance or use separate isolated instances. You get on-the-fly selection of instance types as well as prepackaged SageMaker environments. So in this notebook, for example, I'm using a 4 CPU and 16 gigabyte instance with a GPU instance. With this flexibility to switch instance types, you can save a lot of money. So for example, if I'm done taking advantage of a GPU, I can just click here, and I've got a set of fast launching instance types. Instead of using this expensive GPU instance, I can just downgrade to an M5 large, for example. And when I do that, it will automatically switch this particular notebook to run on that cheaper instance type. So that's pretty flexible. What you can also do is you can see that I'm using a TensorFlow 2 kernel here. For any new notebook, you can pick whichever type you want. And the last thing I'll show you quickly is that you can also share your notebook easily with other Studio users. That'll give someone a snapshot, and they'll get a read-only copy of what you're doing, letting them see where you are in your work. So that's another way that you can collaborate. On the left side of Studio, there's a number of different panels. For example, you can access your Git repos with this panel, or look at the Studio file system with this one. Here I've got the SageMaker examples repo open, where we've got over 300 notebooks for you to easily and quickly get started. So if I wanted to look at a debugger example, I could just open that folder, pick a particular topic, launch a notebook, and I can easily step through and get a full end-to-end example of that particular topic. Coming back to the root of the file system, I've got a few different repos here that I'm using. We're going to be going through a model monitor example that Stefan had put together. Okay, and to make a new notebook, you can simply click on this plus sign. That gets you to a launcher. You get to pick which kernel you want. Let's say I wanted PyTorch. Then I could just simply click here to launch a new notebook. Okay, so let's get to our example of the day. Here's a notebook that we'll be using. So our use case today is predicting whether credit card holders will default in the next month. So we'll use SageMaker's built-in XGBoost algorithm to train a logistic regression model, but first, let's do a bit of pre-processing and feature engineering. Here's a few rows of our labeled data set. We've got the card balance limit, demographics, billing and payment history, and a label indicating whether or not this particular account is going to default in the next month. We've got some categorical columns like marriage that have been integer encoded. And then we can take a quick look at things like class imbalance. Here, we're in pretty good shape. We can see that about 25% of our training data will default in the next month. Here we're doing a correlation matrix for all of the features. Then we've got a look at the billing and payment over the last couple of months to see if we can learn anything from that. So I'm sure you can imagine a lot of different ways you could do additional analysis and data exploration, and Studio notebooks are a great place to do that kind of work. After you've had a chance to analyze and understand your data, you'll do some work on data transformations and feature engineering in your notebook. So to keep things simple in this case, we're just doing a train test split and saving and a little bit of feature scaling, and then we're saving the resulting training and testing data to feed into the training step. Now, as your pre-processing ideas get a little bit more solidified and you get onto larger scale data sets and more complicated logic, you start to think about reproducibility and performance and cost, and that's why SageMaker processing jobs were added to SageMaker late last year. Processing jobs let you easily run pre- and post-processing and model evaluation workloads all on fully managed infrastructure. So you provide a script and you let SageMaker spin up a set of instances, distribute the input data for you, and run your job. And when the job is done, SageMaker moves your output to S3, shuts down the compute, and you only pay for the compute time that you used. No need to worry about managing your own set of EC2 instances. So let's see how easy it is to run a SageMaker processing job. So instead of doing this kind of work in your notebook, here we're going to first upload our input data, the raw data, to S3. That'll get fed to our processing job. Here we instantiate an sklearn processor object. This is taking advantage of a built-in processing job container. And we're going to move the kind of code that we would have done in the notebook into a script. So here we're just writing that code into a preprocessing.python script. You'll notice there's no magic here. The same code that we were doing in the notebook, we're just moving it into a script. Here we actually just run the processor and we tell it where our code is, where the inputs are located, where the outputs should go, and then the arguments that should be passed to the script. In our case, we're just passing a train test split ratio of 20%, and then SageMaker will take over from there. So that's when it does all the heavy lifting of spinning up instances, running your job, and moving your output to back to S3. So be sure to try out SageMaker processing. It's a really flexible and simple way to scale out your ML processing and model evaluation jobs. So with that in place, we can use the results of the processing job to train an XGBoost model. And as part of this step, let me show you another cool capability called SageMaker Experiments. This lets you organize, track, compare, and evaluate your ML experiments. So let's say you're coming up with a new computer vision model and you're doing a number of experiments to come up with the most accurate model. This is going to be very iterative. Project could take weeks or even months. As part of that, you'll try out hundreds of different parameters, different flavors of image augmentation, even some optimizations for training time and for cost. You can literally end up with thousands of training runs and model versions, each with its own metrics and output artifacts and hyperparameters. So what you really need is a scalable way to organize and keep track of all that work, letting you evaluate and compare results and have some way to explain those results to your team and even your business sponsors. SageMaker Experiments gives you exactly that. It lets you access all the details on exactly what data was used on each experiment, how it was configured, what parameters were used, and even the model metrics. This is also great for troubleshooting and auditing as well. So Experiments does this by giving you a flexible API, and we're going to show you that in this example. So here we simply create a brand new experiment. We give it an experiment name. You can give it a description. With that experiment in place, that can act as an overall container to hold a set of different trials, thousands of trials, let's say. Here we're creating our very first trial, so we say trial.create, give it a trial name, associate it with a specific experiment, and so now we've got both an experiment and our first trial. Next, we'll show you how to create a trial component and put that into a trial. And here we're showing a way to create a custom trial component with this tracker API. So we can give that component a name, pre-processing, and you can add in a set of inputs. You can also add in the parameters that you're using for that particular part of your experiment, and so forth. Once you've got that component in place, you could do things like look at its parameters, but the key thing is here we're adding that trial component to the trial. So we created an experiment, then a trial within that. Now we've created a trial component within that experiment. So Studio gives you easy access to all of that visually. So if I click on this experiments panel on the left, here I've got a set of different experiments that I've been doing. If you double click on an experiment, you can see the set of trials. In this case, I only have one trial in there, but you could easily imagine tens or hundreds or thousands of trials on this one experiment. If you expand on that trial, you can see these are the different components that I've added to that trial. This is the one that I just showed you, but I've also, a few days ago, did a training job and a batch transformation as well. For any of these components, you can right-click and open the trial details. So here I've got the pre-processing. I can see the set of parameters. Remember, I passed the random state and the split ratio. And here are the artifacts, where I'm getting my raw data, and various output artifacts. And then I'll show you how to add in training as well. So this Studio gives you a visual way to navigate across a hierarchy of your experiments, your trials, and your trial components. And you can easily drill into the details, and you can even compare and contrast different training runs and chart those results easily. So coming back to our example, let's take a look at training the model. So SageMaker lets you easily train your models on fully managed infrastructure without the burden of managing your own clusters. So by doing that, you're really optimizing your training costs by not having to worry about utilization, and you're eliminating the heavy lifting of allocating separate instances and making sure that you keep that utilization high, and keep those instances patched, for example. So in this case, we're using a built-in XGBoost algorithm, but you can also bring your own training scripts for frameworks like TensorFlow and PyTorch and MXNet, and that's also very easy. And lastly, you can bring your own containers if you've got other more specific requirements. So since model training is directly integrated with experiments, the training job can be tracked as part of the trial as well. So here I'm calling XGB fit, And the only extra parameter that I'm going to pass is this experiment config parameter. And I'll associate it back with the trial that we created earlier, and I can give it a trial component display name. So remember, back on the experiments panel, that's why this showed up as a train component. And I've already run this training job, so I can open that up. I can see it created some charts for me, and I can get easy access to metrics, the hyperparameters that were passed to that job, artifacts, different settings like what infrastructure I used and so forth. All of that is now explicitly part of that overall set of trial components that are part of my specific trial. So that same type of integration where you can simply just pass an experiment config parameter, that's also provided as part of processing jobs and batch transformations, as well as our autopilot capability. So these things can all easily show up as trial components alongside with any custom trial components that we showed earlier. So lastly, SageMaker Experiments also gives you a searching API. This gives you a flexible way to sift through all of your experiments and extract specific information you need for analysis or for reporting or auditing purposes. Here we're simply getting a data frame of all the steps that went into a specific trial, and then we drill into the specifics of a trial component. Here we're doing a describe trial component on one of the specific trial components in our trial. We could have just as easily done a search across all components, all trials, or even all experiments as well. One last note is that although I'm showing you this in SageMaker Studio, note that processing jobs and experiments have a complete API that's fully independent of user interface. It also, they each also have a command line interface, so you can use these in SageMaker Classic notebooks or whatever environment you need to use them from. So with that, let me hand you back to Stefan, who will take you through the rest of the demo.
Thank you, Mark, for walking us through the data exploration, SageMaker processing, model training, and SageMaker experiments. Now, once you're done with your training jobs, a key differentiator of Amazon SageMaker is that you can deploy the model for both offline and online inferencing in a few lines of code or in a few simple clicks. Let's talk about offline inferencing first. Here we will use a capability called SageMaker Batch Transform. Using Batch Transform, you can scalably and efficiently run inferences against large volumes of data at low cost. Similar to training jobs, as we shall see, SageMaker will set up the underlying infrastructure, copy your data over to a local instance or a local storage on the instance, run the inference, and store your outputs back in Amazon S3. So you can think about using Batch Transform when you don't need a persistent endpoint, or if you want to quickly get inferences from large data sets. Let's see how that works. So here I have my test data again, and I'm just going to go ahead and drop the label column on the test data because that's the prediction that we want our model to make. I'm going to store that test data without the label column in S3, and now I'm going to pass that as an input to my batch transform. To run the batch transform is really as simple as a couple lines of code. I simply call my XGBoost model this transformer utility. This one is for the number of instances that I want to run on. Here I have the instance type, and then the serialization that's associated with the model that the input that the model is going to see. And in this case, because it's a CSV data set, I'm going to pass in this text/CSV. Once I've set up this transformer, I simply call transformer.transform, passing it the data location for my test data, and off it goes. Now, similar to the training jobs, as Mark explained, you have the option here of associating this transform job as well with that particular SageMaker experiment. And this way, other data scientists can take a look at the job that you have ran and see the outputs and the output metrics potentially as well. So here you have the option of specifying a trial component, a display name associated with that. I'm just going to call it batch transform, and then a trial name. Now, SageMaker, as I said earlier, will set up the underlying infrastructure, it'll run the batch transform, and it'll generate the outputs for you, and it'll do all of this in a fully managed way. Once this is done, the outputs from your batch transform will be stored in Amazon S3 in a file with an extension called .out. So we can pull out that file and take a look. And what we see here is that for each of the rows in the dataset, we now have a label that's associated with it. The reason this is a floating point is that the way SageMaker built-in XGBoost model works is that it actually predicts a probability as opposed to a binary label. But we can convert this very easily into a binary label by simply rounding it up or down. Now, what this allows you to do is to do all of the standard things that data scientists are familiar with, for example, extracting things like accuracy score. So for example, in our data set, because the data set was slightly imbalanced, if we had chosen a naive model that always predicted that customers would not default on their credit card loan, that model would have about 77.8% accuracy. And here we can see that by using the built-in XGBoost, we've been able to beat that accuracy on the unseen test data set. We can also do things like generate a confusion matrix, or if you want, you can generate precision recall curves and ROC curves. So that's, in a nutshell, how SageMaker Batch Transform works. The next thing I'd like to talk about is how you can now host this model as a persistent endpoint, and in particular, set up model monitoring. The reason model monitoring is useful is that you may want to monitor your endpoint for any data drift or any model drift. And for this reason, I'm going to talk about a new capability that was introduced with SageMaker Studio called SageMaker Model Monitor. Before I show you the code on how to set up model monitoring, I want to quickly walk you through a couple slides on how model monitoring works behind the scenes. So I'm going to quickly open up my PowerPoint. So once you've deployed your model, you probably want to set up SageMaker Model Monitoring in order to monitor your models for data and model drift. So here's how model monitoring works. The first step that you need to do is that you need to set up a SageMaker endpoint so that can receive requests from incoming client applications. Now, as the endpoint starts to receive requests, you have the option of storing not just the request itself, but also the predictions. And these are saved for you in an S3 bucket. And all of this data can be captured. You can choose to capture either all the data or a fraction of the data, particularly if you have a high volume endpoint that's receiving a lot of requests in time, as this can increase your storage costs. Now, once you've received the incoming requests and the predictions that your model has made, in order for model monitoring to monitor that endpoint and that data for any drift, it needs to have a baseline. So the next step that we're going to take is we're going to establish a baseline by looking at your training data. Model monitoring will use the DQ library that is built on top of Spark under the hood in order to automatically extract statistics as well as some default constraints from the training data set that the model was trained on. Now that it has the statistics and the constraints, it can compare the stats and the constraints against the incoming predictions. And in order to do that, we're just going to set up a scheduled job, a cron job, in other words, either on an hourly basis, a daily basis, or a weekly basis, to compare the incoming requests and the predictions against the baseline that the model was trained on. The model monitoring service will find any violations and report those violations and store them in an output bucket in a JSON format. Additionally, it'll also send metrics to Amazon CloudWatch that your data scientists and data engineers can potentially use to set up alarms to notify them when they should go back and retrain their machine learning model. So with that intro, let me now jump into my studio environment again and show you how model monitoring works. All right, so before I show you the code in order to set up SageMaker Model Monitoring, let me show you what this looks like in the Studio UI itself. So here I have a bunch of endpoints that I've deployed previously, and you can see all the live endpoints that you have by clicking on this button right here in your SageMaker Studio tabs on the left that Mark was showing us. If you click on this button, you'll see all of the endpoints that you have, and here, as you can see, I have 4 in service. Now I can click on any one of them, and if I right-click and click on Describe Endpoint, I'll get a screen that looks like something here on the right panel. So let's take a look at this in a little bit more detail. What I've done for the purposes of this demo is that I've taken the test data set that we previously had, and I've modified that data set to create some fake data. In particular, I have taken some of the features like the age feature, and I've reduced everyone's age by about 10 years. I've also reduced the amount of credit card bill that they had to pay for a specific month. and I'm passing this new modified test data as input to my endpoint. So let's see if my model monitoring job can capture any of this modified drift that I have in the data set. So the first thing you'll notice when you set up an endpoint and you have model monitoring is that the model monitoring will be running on an hourly schedule. As you can see, my last job here ran about 32 minutes ago, and then previously I had a job that was running about on the hour for the last few days. And you can see that it has found some issues. Now you can click into this and drill down into specific issues that it has found, but it's also useful to just visualize the outputs of the model monitoring job itself. And here, to do that, you can go to the monitoring results tab. So here you can see that I have one of the features, which I did not actually modify. And for that feature, I have no drift and nothing has been detected. In other words, the current value, the drift from the current value is in fact 0. Now, if I look at another feature, I mentioned earlier that I had modified the age. So here you go. What you can see is that compared to the baseline, which is shown here in blue, I have reduced everyone's age by a factor of 10. And indeed, the model monitoring service is able to capture that drift in this particular feature and can plot it automatically for you. Similarly, that bill amount that I had changed, that drift has also been captured. Now, if you want to make additional plots beyond the one that I've shown here, you can simply click on the Settings tab, and this will allow you to make additional plots. In order to do that, you click on the Add Chart capability, and that will open up a new chart, and it'll allow you to generate plots as a function of time, either on a daily, hourly basis. You can look at specific statistics and then pick which feature you want in order to make the plot. So let's go ahead and see how I set all of this up back in that Studio notebook. So going back to the Studio notebook here, as I mentioned in the slides, there are a couple steps that you need to take in order to set up model monitoring. So first thing we need to do is to set up that data capture configuration. So here, all this really entails is specifying the enable capture flag to true, which tells the endpoint that it needs to capture the incoming payload. You can specify a sampling percentage. Because we're not going to be sending a lot of data in this demo, I'm just setting that percentage to be 100%. And we specify the output path where we want that data to be captured. Deploying the model in SageMaker is just a single line of code. We specify the number of instances we want to deploy on, the instance type that we want to deploy on, and now we pass this data capture configuration that we specified here as an additional parameter. And SageMaker will take care of setting up the underlying endpoint for us. Once the endpoint is set up, we can take a look at what that incoming data capture process looks like. So here I have some sample data, and I'm going to just run an inference against my endpoint by calling this predictor.predict function. Once I do that, I will see that a couple of files will start to pop up in the JSON lines format, which is capturing that incoming input payload. So I open up one of these JSON lines format. It's going to look something like this, where you will see the incoming data or the features that your model can accept, and then also the outcoming model output that was generated from the inference from your endpoint. So now that we have this set up, the next stage is going to be to set up the baseline. So here I'm just specifying some S3 bucket paths where I want the baseline outputs to go. But in order to set up the baseline, all I need to do is call this default model monitor utility, pass in some infrastructure parameters, but mainly I need to pass in the training data location. So that model monitor knows how to set up, knows where to go in order to set up the baseline. I specify the dataset format, in this case is CSV dataset, and I'm done. Model monitor will use the DQ library that is built on top of Spark in order to extract statistics from this training data and output those in two files. The first file is called statistics.json, and the other one is constraints.json. So if I look at the statistics file first, you can see that I have the inferred data types for each of the features. I have how many data points I have present or whether I have any missing values. And then I have general statistics such as the numerical mean, the sum, the standard deviations, as well as some KLL sketch parameters associated with the data set that are also automatically generated for you. Note that this is something that you don't have to write any custom code for. The model monitoring service is going to do all of this for you automatically. Additionally, it's also going to generate this constraints JSON file. So if you look at the constraints, you'll see that there are a few constraints that it's found automatically. In particular, it specifies a certain inferred type for that for the data types associated with these different features. But another key constraint that it has identified is, are these various features allowed to be non-negative, for example? So it'll look for violations against those constraints as well. Now, once you have the constraints file and the statistics extracted, you've set up the baseline, the last thing we need to do is to create our monitoring schedule. So we simply pass in the name of the endpoint where we want to set up the schedule on. We specify an S3 path where we want the reported outputs to go. We pass in the baseline statistics, and then we create this cron expression in order to set up the monitoring schedule. And this can be daily, hourly, or weekly. Now, a common question that customers ask us is, what if I want to do some custom pre or post processing here on top of what the model monitoring job will output? You have the option here of passing a pre-processing Python file as well as a post-processing script that model monitoring service will copy over to the container that it's creating for you when the model monitoring job is created, and pre or post-process the data that is coming from the endpoint or that's coming from the model monitoring job if you wish. You can also set this enable CloudWatch metrics flag to true, and this tells the model monitoring service to pass on the drift that it detects to CloudWatch so you can set up things like CloudWatch alarms. So let's go ahead and take a look. This is my test data sample, and as I said earlier, indeed, I have gone ahead and modified some of the features to generate some fake test data, and I'm going to simply repeatedly invoke my endpoint by calling this invoke endpoint forever function. So what I'm doing is I'm taking this fake test data, and I'm simply calling my endpoint over and over again with this fake data. And the outputs of that is what I showed you earlier in the Studio UI. Now you can also visualize the outputs as APIs, because these are ultimately all APIs in the backend. So let me just scroll all the way down to show you what these outputs will look like. You can see that the model monitoring service, in addition to constraints and statistics.json, will generate a third file called constraint violations.json anytime it detects a violation. You can open up this file and plot this, visualize this as a data frame, and you can see that I'm indeed able to detect drift from a number of features that I had modified. So the age, I'm getting a drift there, as well as a drift from the bill amount. So the last thing we want to talk about before we end this session is another neat feature associated with SageMaker training jobs that, in the interest of time, we did not have a chance to show you in the studio, in our notebook demo itself. So I'm going to switch back over to my slides now and quickly walk you through another feature called SageMaker Debugger. So SageMaker Debugger provides full visibility into the training process by automating the process of capture and analysis of data from your training runs. SageMaker Debugger is particularly useful when you have those long-running deep learning training jobs, such as computer vision jobs, or just general deep learning jobs that might take several days or several hours or potentially even weeks to complete. SageMaker Debugger will automatically detect and alert developers of commonly occurring errors in deep learning jobs, such as vanishing gradients or exploding gradients. You can also use SageMaker Debugger to create a custom set of rules that you might want to monitor your models for. For example, the way to use SageMaker Debugger is that you can use the SDK to automatically detect new classes of model-specific errors or interactively analyze training runs in the SageMaker notebook. As a result, SageMaker Debugger reduces the debugging effort for machine learning models from days to minutes by providing complete insights into the debugging process. The data that's collected by SageMaker Debugger remains in your account, and only you have access and only you can see it. So to give you an example of how SageMaker Debugger would look like in your studio environment, here I have a TensorFlow estimator. I'm running a TensorFlow job on a GPU instance, and I point, in addition to the training job, I specify a set of rules. SageMaker Debugger comes with a set of built-in rules. These are available to you for no cost. Some of these rules include, for example, monitoring for things like vanishing gradients or exploding gradients, or in the context of XGBoost, looking for things like Shapley values and the evolution of Shapley values and feature importances as a function of time. You can also specify custom rules, such as is your model overfitting, by generating a custom rule script and passing that script as an entry point to SageMaker Debugger. The debugger process will automatically, as your training job is happening, look for violations against these different rules. And similar to that model monitoring demo that I showed you, you will see in your SageMaker training job this time, you will see a tab called Debugger. And if you click on this tab, you'll be able to see if there are any issues found. So for this particular, in this particular screenshot, I have issues found for both vanishing gradient as well as overfitting, and you can go ahead and plot this. So for example, if I plot my loss function here, my cross entropy loss here as a function of time, I can see that in fact my loss is not really changing as a function of time, and this could be an indication that my model might be overfitting. So in this way, SageMaker Debugger can dramatically reduce the amount of time it will take you to run your training jobs and debug your training jobs, and you can choose to use Debugger to stop your training as an early stopping mechanism, for example, to ensure that you don't waste months, waste hours or weeks training jobs that are not optimizing further. Now, having shown you all of these different capabilities of Amazon SageMaker, another key differentiator of SageMaker really comes down to the cost. When you think about costs for machine learning models, you really want to be thinking about the total cost of ownership for your machine learning platform across the build, train, and deploy lifecycle. And in particular, you want to think about the underlying infrastructure cost. So for example, you might say, hey, I have 25 data scientists that are building models all day long. I need the lowest possible price per instance hour of compute. Additionally, there are other things that you might want to consider. For example, how long does it take to operate that environment? How are you making sure that you have good utilization? And what about things like security and compliance? How long does it take the IT teams to put together the correct security and compliance guardrails that you might need? Having a managed platform like SageMaker, like Amazon SageMaker, can dramatically reduce the amount of time that it takes in order to set that up, thereby reducing your total cost of ownership. In fact, with Amazon SageMaker, the TCO is about 54% lower than if you were to build all of this by scratch using a self-managed approach. Additionally, hopefully, as we have shown you today in this webinar, developers can gain productivity gains of up to 10x by using some of the various tools that we have shown here. So before we close, I just want to leave you with a number of resources that you can use to get started on your journey on SageMaker Studio. We have a number of blogs on some of the topics that we talked about, such as model monitoring, SageMaker processing, SageMaker debugger. We also have our email aliases for both Mark and myself here on the slide, and a whole host of getting started tutorials that you can use. In fact, the notebooks that we showed you today will also become part of a getting started tutorial that should be available in the coming weeks. So simply go to aws.amazon.com/getting started, and you should be able to find this tutorial there in the next couple of weeks. So thank you very much for your time, and we'll take questions. Thanks.